Good morning, good afternoon, good evening to everybody watching. We are here to take you through a intensive deep dive course on Watermelon's functional testing capabilities. If all goes well, then by the end of this course, you should be self-sufficient and independent in order to use Watermelon's platform to do your functional testing automation with zero coding in a variety of complex applications, whether it is web applications or mobile applications. Watermelon has a lot more to offer, but we are going to stick our scope of this deep dive course to functional testing on web and mobile. We're also going to start with an introduction to the Watermelon platform itself and a few administrative aspects before dumping or jumping into the actual automation aspects of things. Now, typically, we do this program in a live classroom where I'm standing in front of a whiteboard and actually giving this course. So here we are doing it virtually. So I'm going to pretend that you are pausing the video at the right times, going ahead and checking the concepts that we are talking about, and consuming the information in a manner like where you would in a classroom where you could ask questions and get concepts cleared. Now, right off the bat, the prerequisite for this course is that you have some basic idea of testing and automation programming, right? Anything basic. We are not looking at expertise. We are not looking at you being an expert at testing or anything, but a background in programming will help you get the concepts being spoken about. Because we are not going to start with the basics of what testing is. This is not a course on testing. This is a course on how to use Watermelon's platform, right? So, for instance, if you're somebody who does not know what a variable is, who is not familiar with the concept of what a global variable is and how it differs from a local variable, if you don't know what loops are, if you don't know what string manipulation is, you might find it difficult to follow along the course. So, let me start with something that you may already relate to. In most teams today, right? Test cases are written in one place. Automation scripts are written somewhere else. Execution often happens in a third place. Defects are tracked in some kind of a defect management tool. And a big issue in all of this is that when people want to automate testing, the amount of skill required is very high. You need to be basically at a development level skill set in order to actually do automation testing. That combined with the fact that everything is disconnected, it's like trying to cook a meal, which is anyway a very skillful task, with the ingredients in one room, the stove in another room, the recipes in another room, and so on. So you spend more time managing things than actually cooking. So it sort of makes sense to look and understand this problem a little deeper before we move on into the software. Why does the industry need something like a watermelon to even exist? What is the software testing challenge? The first part of testing where the challenges start coming in is that requirements documentation itself is very fragmented, right? In every software release, the requirement that comes in, and for those of us who have any experience in testing know that it kind of comes in as a one email, a line in an email, and the actual software documentation and design documents are lying in different repositories. It's very, very fragmented. A second part of the challenge is that in any large enterprise, you don't have all your systems built on the same technology. A lot of technology is still very legacy, is still very old, is everything is not snazzy and new generation built on latest technologies, which everybody can sort of automate the testing of. A third problem, which again, anybody who's done any kind of testing or any kind of programming really knows, is that enterprise flows, which are to be automated, are really, really lengthy and hard to maintain. So even if we are talking about a flow which is a priority one flow for an enterprise like a bank, let's say a funds transfer, you're talking about logging into the internet banking or mobile banking portal, selecting the list of available source accounts, validating whether the right source accounts are there, selecting the destination account, validating that all the destination accounts are there, validating the balance, going ahead and executing the transaction. validating a OTP which comes from a third party system, making sure that the right amount gets transferred from the ledger and the books are balanced, making sure that a transaction number is generated, making sure that an invoice or a transaction report is maintained for regulatory purposes, and so on, making sure that a database entry is made at the back end to balance the books at the end of a batch cycle. Even something as simple as what takes like 30 seconds to do on the screen is a very lengthy backend automation in order to test all the validation points. Which leads us to the fourth problem of software testing. All of this has to be done with limited time and resources. Nobody has infinite number of testers, let alone infinite number of automation testers who have high skills. Yeah. And very often, what happens as a result of all this is that companies and enterprises just give up on end to end testing across different platforms. It's nearly impossible. For example, in insurance industries, you apply for an insurance policy, you get a legal document in the form of a PDF, you go ahead and buy an insurance policy which results in a policy number, and that actual entry is done in the back end across the world in a system which is, let's say, on AS400. And AS400 just can't be scripted with traditional tools that are available in the market. So people go ahead and disconnect the back end from automation testing scopes. Yeah. Which, of course, goes ahead and leads to a big problem in testing, which is a lack of coverage due to human beings going ahead and writing these test cases manually. Right? Now, just like having legacy systems is a problem, because the pace of technology is so fast and newer tech stacks keeps coming up every day, the latest tech stacks being used by developers are often not very testable by testers. That's another problem, which basically means that to go ahead and actually automate software testing needs a very high degree of programming skills. And to have somebody who has programming skills and also the skills which require understanding of the business domain, these are nearly impossible to get in the market. Added to the fact is that because of the dynamism of the business keeps asking for changes. And the number of application changes being asked for is, if anything, more today than it was 5 years ago. And despite companies investing in huge number of testing experts, testing tools, this problem has never really been solved in the market until Watermelon came along. Production issues still persist. This is the universe or the ecosystem in which Watermelon was born and the problem that it is out to solve. That is the basic problem that the Watermelon platform tries to solve, right? It's a unified platform for software testing and reliability. So instead of using multiple tools for requirement management, defect management, automation of web, automation of mobile, doing other kinds of non-functional testing, virtualizing services, you can basically design test cases, create test cases, automate them, execute them, analyze results, all of that in one place. So another way to think about it is Watermelon is your control center for reliability for your entire application across the SDLC. Everything flows through it. Now, inside Watermelon, there are multiple modules, which is what you're looking at. You don't need to master them all right now, and we are not going to go into each of them in this course, but you should be aware of what they do. The first module that you're looking at, this is where we'll be spending all our time, which is called the Autonomous Functional Testing module. This module helps you automate web, mobile, legacy applications like green terminals, AS400s, desktop swing applications, and so on. It can build test flows without any coding. It can execute end-to-end scenarios which are cross-application in nature. For example, if user journey starts with a mobile application, goes to a web application, goes to some backend systems, automation of databases, automation of validations with Excel sheets, calling APIs, all of that can be done in this one module. This includes requirement management, defect management, and so on. It also includes the capability to automatically generate business requirement documents and test cases at the beginning of your SDLC. The second module that you're looking at is If your application has APIs, which almost all applications do, you can test them out here. You can essentially do the testing of the functionality of your APIs without writing any scripts. You can call APIs, validate their responses, and you can also combine the API testing with your UI testing, yeah, using the second module. The third module that you're looking at, which says chaos engineering, this is a little more advanced. Here, you intentionally break parts of your system to see how it behaves. For example, what happens when a service goes down? What happens when certain infrastructural components break? Does the user journey still work? We won't cover this deeply, but it's part of the larger platform and it addresses the larger problem of application reliability. The fourth module that you're looking at is the SLO management module. This is something that runs after a software is released, and this is about monitoring reliability in production. So it answers questions like, is the system meeting reliability goals? For example, in the 10,000 transactions that users are performing, what percentage of those transactions are throwing errors? And is it within my tolerance limit? What percentage of those transactions are performing within latency criteria that I've set? Are any users expecting, is the application behaving in a way which will make users experience bad performance? Again, not the focus for this course, but important that you know what it is. And the last module that you see is called service virtualization, where Watermelon actually helps you create mock up services which don't exist at the time of application creation. Let's say you have a bigger journey, you have a situation where something starts off in a web application and somewhere down the line a API call is made to a authentication government service. You don't have that service at the time of development and testing. Service virtualization helps you mock up those services. Now, for this entire course, we are going to focus on the autonomous functional testing module. This is where you'll build automations, execute flows, validate application behavior. Before we go deeper, let me quickly show you what you'll be able to do with this. You're going to basically be able to open up any application, go ahead and use it, uh, go ahead and create test cases without the need of coding. No need to write any code. You're working with blocks and actions, and you can execute the test, look at its logs, figure out what the defects are, raise defects, send them back to your engineering team. That's the key idea: readable, maintainable automation. Let's also be clear, this course is meant to be a hands-on follow-along course. So you are actually going to be able to pause the videos, do the exercises that we are talking about by repeating it on the software that you already have access to. Which brings us to the important prerequisite that if you want to follow along the Watermelon functional testing automation along with the videos, you need to have access to a Watermelon sandbox. This will be provided to you by any sales team in Watermelon. Drop us a line if you need that and you want to get access to that. Let's move on to something deeper.